Hello once again, and welcome to the assignment, which was formerly an in-class assignment, called Hypothesis Testing, Correlations, and Experiments. In this tutorial, I will show you how to um, do the worksheet, and I will go through an example of how to do it with my own, I guess example would be the right statement, so that sounds redundant. But nevertheless, I will give you an example of a saying or proverb, and I will do it, I would say, with you guys, maybe for you guys. Hopefully, you're following along just as I do it. And then I will let you choose one of the proverbs below, or if you really want to, if you like a good saying or proverb that you don't see on this list and you want to use that to, oops, to use as your assignment, then by all means, go right ahead. So, in this assignment, which goes after chapter 3, where we talked about the 3 types of claims, we are going to focus on the last 2 of those claims. So frequency claims are not going to be discussed in this assignment, but we will be talking about association claims, which we call correlations. And remember, in chapter 3, I said that if the correlation is high enough, either positive or negative, depending on the relationship of the variables, then it may actually show that there could be causation. I know that correlation does not imply causation, but in this exercise, what we are going to do is um, do a correlation and look at the results. And if the results will assume that our correlations are high enough that we want to then test it as an experiment. So we will go from 2 measured variables. We call them the criterion, and why am I drawing a blank? I don't know. Anyways, the 2, you'll see. Predictor and criterion, that's what I'm trying to say. It's right in front of me. So we will take a proverb and operationally define it so that we can specifically measure it. And then we will make a correlation. And based on this, we will see if our correlation is positive or negative. And after that, we will then turn it into an experiment by turning it into one manipulated and one measured variable, as in an IV and a DV, as opposed to a predictor and criterion. So let's get started with that. For this exercise, it says you will first be assigned a proverb in this case because you're all working on your own. Although if you do want to make a Google Hangout or something with other people, or call them on the phone or something like that, if you really want to, then sure. I don't really mind if you do this since it was originally a group project anyway, assignment. So for this exercise, you will choose a proverb. You are then to propose a way to test this proverb using part 1, the correlational method. And then, if we consider the correlation good enough, let's use the experimental method. So part 1, using the correlational method. First, you're going to take a proverb and translate it, translate it or operationally define it into a testable hypothesis. So first, you want to formulate your operational definitions, which will allow you to test the proverb in question using that correlational method. Your operational definitions need to satisfy 2 criteria. Number 1, they should clearly define the operations or procedures that will be used to measure both the predictor and criterion variables. So I should know very clearly how you are intending to measure this. What is the definition of how you're measuring it? And 2, they should capture the meaning of the variables in question or the idea expressed by the proverb. That is, they should have good construct validity. So, based on this, we are going to take a proverb and we are going to operationally define it into 2 measured variables. And then we are going to describe the type of relationship that would be obtained between the predictor and criterion variables if the results are to be consistent with our hypothesis or proverb. So basically, what you will find is that there is either going to be a positive or negative correlation. If it's zero correlation, like we talked about, 2.5 possibilities, then we really don't have anything more to do with this. So we're not doing things that way. We are going to look at the relationship between them. And just to remind you, if both variables, right, as one goes up, the other goes up, or as one goes down, the other goes down, you would call that a positive correlation. If one is going up and the other number is going down as the one goes up, or vice versa, then that would be a negative correlation. And then we are going to assume that the correlation is high enough, either positive or negative, that there may be an actual relationship between A and B. So when for part 2, we'll be using the experimental method. And in the experimental method, we are going to translate our proverb into a testable hypothesis. So we are then going to now formulate, instead of predictor and criterion variables, we are going to formulate operational definitions that will allow you to test your proverb experimentally. Remember that the operational definitions you propose must clearly define how the independent variable or variables will be measured in your experiment. So you may need to get a little more specific than you were originally, at least with the independent variable. They should also capture the meaning of the variables in question or the idea expressed by the proverb. That is, they should have good construct validity. After we get our hypothesis, then I want to know about control procedures. So to remind you, for the example that I gave in the lecture, throughout the first few chapters, I talked about our studying experiment. So in our studying experiment, I gave 2 groups. One was 0 hours of studying. That was my control group. My experimental group was 6 hours of studying per week, which is that Carnegie unit. And then I said, in order for us to know that it's A and only A, remember, for internal validity, A and only A that causes B, so the studying and only the studying that causes the exam scores. I don't want anything else that could potentially be a confound to explain it. So one of the things I mentioned in the lectures a few times is that we want to control for a few things. The first thing that I talked about is control for caffeine, because caffeine may boost learning memory and may help you where it is unwanted in this case, because we want to know that it's the studying and not something else like caffeine that causes you to do how you do on the exam. So the control procedures that I talked about in regards to that study was nobody gets caffeine, everybody eats the same breakfast, and then we would essentially take the exam maybe an hour after breakfast, and everybody gets the same amount of sleep if we could control for that. So these are what we call control procedures. So depending on how you decide to manipulate your independent variables, how you define your experimental and control groups, you will need to control for the influence of these certain extraneous variables. So what I want you to do at the end of part 2 is decide maybe 2 or 3 variables you believe that would be most likely to influence the behavior of your subjects, and then describe how you would control for those influences. So for my studying example, like I said, I would say nobody's allowed to have caffeine. I would say same amount of sleep. I would probably say, right, eat the same oatmeal for breakfast. Nice brain food, nothing too heavy or sugary, or not eating nothing. And I could also go as far as to say that anybody that is taking this class for the second time, if you took it before, I'm going to eliminate you from the study, right? So that way, even somebody that may have been exposed to the first exam already in a past semester, then they are eliminated, whether they're in the studying group or the non-studying group. It doesn't matter. So You may limit your discussion to those procedures you think may pose the most serious threats. So try to come up with at least 2 or 3 if you can. But you must indicate at least, this says one potential variable. I'm going to say 2. So listen to me, not the paper. And I will probably edit that as best I can. So going down on the next page, again, predicted or expected results. We have, this says describe and illustrate with a figure, but you don't need to do that on the computer. So just describe what's happening, and that would be consistent with your hypothesis. If you want to, write it on a separate piece of paper and draw it, or if you're good at making graphs, online, more power to you. You can also draw it on a piece of paper and turn in your paper as a picture. Take a picture of it with your phone and upload that if you want to. So that way you can use a graph if you want. Otherwise, you can just describe what you'd see. So next to my sheet here that has all of the proverbs and the directions on it, I have an untitled Google Doc here, which I'm just going to use to make my notes from what we talk about, or what I talk about to you. So my example here is an apple a day keeps the doctor away. I'm sure that pretty much every one of you have at least heard that phrase, or that, proverb, cliche, whatever you want to call it. You've heard this line before. So remember that we're practicing this idea of conceptual definitions versus operational definitions. So that's what we are going to sort of practice along with this. Now, I'm going to show you really quickly the other proverbs that I have written down. And again, I'm always willing to take some out that may be too difficult, or add some ones that other ones that people like to use. Maybe these are a little outdated and there's some better ones in a more modern time. I don't know. But here are the ones that you guys have to choose from. Slow and steady wins the race. It makes me think of the tortoise and the hare. Too many cooks spoil the broth. Absence makes the heart grow fonder. Blood is thicker than water. Spare the rod and spoil the child. 2 wrongs don't make a right. Fortune favors the bold, and birds of a feather flock together. So those are the ones that I have that you can choose from. Or, like I said, if you really want to, you can come up with one that is not on this list, as long as you have a good definition for it. But for the time being, so you can see exactly how I want you to do this, I am going to use this example here. An apple a day keeps the doctor away. So if we go here, I'm going to give my I'm going to give my definition, if it lets me type. There it is, definition. So an apple a day keeps the doctor away. Let's just say this is let's go with conceptual definition. Conceptual definition. Healthy eating, right? Healthy eating, which would be apples, keeps you well, or keeps you from being sick, right? It keeps the doctor away. It means you don't have to see the doctor, or back at the time it was probably written, or somebody came up with it. That's when doctors were still making house calls. So it keeps the doctor away from you. In this case, we would say that it keeps you from being sick. And I'll just write that, therefore, seeing or having to see a doctor. Having to see a doctor. So come up with your conceptual definition first, and then we can relate it to a specific definition. So for this correlation, we would say, right? So operational, if you want to do it this way. Operational, as I wish I could spell, definition is eating more apples means less doctor visits, right? So if we were to look at the predictor variable, Remember, we have predictor and criterion. So the first one is apples. And how do we measure that? Well, we would say, oops, number of, not hashtag, number. So I better put a space there. I don't want people to say hashtag apples. Number of apples eaten. And let's say, or we'll just leave it at that. Number of, well, I don't want to leave that too undefined. So number of apples eaten in how long? Because you can just say number of apples eaten in your lifetime, blah, blah, blah. In a week, right? Let's do that. Number of apples eaten in a week. And then we can go over here and criterion variable, which will probably end up on the next line anyway, is number of doctor visits in a year. And yeah, that looks bad. So I will edit that because I can. So predictor variable, number of apples eaten in a week. And the criterion variable is the other measured variable. It's the number of doctor visits in a year. And that's pretty much it for that. You have your operational definition from your conceptual definition, and then your two variables. So if this proverb is your hypothesis, if an apple a day keeps the doctor away, then what would we predict? Well, we would predict, so prediction, the more apples you eat, the less doctor visits you make. So then I ask the question, is this a positive correlation or a negative correlation? And this is where I would ask you guys to answer. So obviously I can't do that. You see an increase in apples and a decrease in doctor visits. So as one variable is going up, the other one is going down. In this case, this is a negative correlation. So if you were to sketch it out as a graph, it would have a line that slopes downwards, not a line that slopes upward, right? From top left to bottom right, going down as a negative correlation. So now is the time where we would say, hey, correlation doesn't imply causation. And I would say, yes, I know, I say it all the time. So, sorry, I need to amuse myself in these times too. Based on that, if the correlation was high enough, and we will always suggest that our correlation is high, then we can say, hey, maybe we can turn this into part 2, which is a true experiment. So I'll just write part 2. Oops. Part 2 is experiment. And in parentheses, I'll just put causal claim. So remember, in an experiment, we still have the same conceptual definition, but this time, instead of a predictor and a criterion variable, we have an IV, and I'll just remind you that it has 2 levels. Oops. With 2 levels. And we will have a control group and experimental group. We also have a DV, which is the measured variable, or it's basically the number that you're getting from this. So number you are measuring, or I should say the number that you come up with, so it's whatever you're measuring. So I guess you can say, what are we measuring? So looking here, originally we have the number of apples eaten in a week. So for the IV, we can say number of apples eaten in a week. Except one thing we know is that that doesn't help us when we have to manipulate this. In this case, we have a control group and we have an experimental group. Right? So In the control group, there's no manipulation. So in this case, this would be defined as 0 apples per week eaten. So you are assigning this. This is a manipulated variable, which means you as the researcher are putting them into these groups. So if an apple a day keeps the doctor away, that means my experimental group will be 7 apples per week. And, hopefully they would eat 1 per day if that's how you want to do it. But you can just say, you know what? I don't care how many you eat a day, as long as you eat exactly 7 in 1 week, right? Doesn't really matter. But if you want to really go by the book, you would say 1 per day, right? So that is your control group is 0 apples per week eaten, and your experimental group is 7 apples per week. So what is our DV then? Our DV, which is measured, is going to be number of doctor visits. And again, we said in a year. But I also think that if this works as the criterion variable for the correlation, but I think I'd like to be a little more specific. And why do I want to be as specific as possible with my operational definition? Because you want to make sure that you're getting an accurate count. So think about this. Why do people go to the doctor? People go to the doctor mostly, right, because they're sick. But some people go to the doctor because they're injured, which isn't sickness. So any sort of like broken bone or bleeding or something like that isn't from being sick, right? So we would say excluding, or in fact, we're not going to say excluding, but let's just go over this anyway. So we don't want people coming in because they have some sort of injury, broken foot, something like that, right? We don't want them coming in for just a regular physical. Most people schedule their physical once a year. So we don't want people coming in just for that. And we also know that sometimes people come in when they're faking sickness, or they may be a hypochondriac. You may have heard that term. People who think they're sick, but it's all in their head. That's a psychological problem, of course. So let's make this more specific. Doctor visits in a year where the visit was specifically for illness and they were diagnosed as sick. Because again, you could go to the doctor and the doctor can say, oh, well, you're actually not bad. You think you're having a heart attack and you have some sort of illness, and he says, oh, it's just gas, right? So that's not what we want either. We want to know if an apple a day keeps the doctor away, if that means less visits because you're actually sick, not because you have a mental health appointment, not because you have a physical, not because you're just doing a blood test. We want to know it's the number of doctor visits in a year where the visit was specifically for illness and they were diagnosed as sick. I just want to be as specific as possible with my operational definition. So I don't have the means to draw a graph here, so I'm not going to. But if we did, on the bottom x-axis down here, it would be the IV. So you would have 0 apples and 7 apples, right? So I could technically draw that, right? Let's see. Let's do a little fun drawing here. So down below this, we would have, right, 0 apples, and we'd have 7 apples per week. And then on the y-axis, which would go up here, we would have the number of doctor visits. And basically, what we would see, right, if you were to draw this, that for 0 apples, our doctor visits would be up here and be a pretty big, right? So I wonder if I could. No, I'm not going to even try. I guess there is a drawing tool here, right? Here we go. Let's see if this works. So for 0, let's make this go up, and this is going to be doctor visits. So I guess I can try and write that. I'll just write doctor because I'm not good with these writing tools. And then let's use blue. And let's look at this. And if you had 0, so I guess you guys could do this in Google Documents as I discover new stuff every day. You would have a bigger number of doctor visits here, and you would have a much smaller number of doctor visits here, right? So this could be your makeshift graph. If I can do it, you guys can definitely do it. I'm sure you're more tech savvy. But so then we can go back to, here's the mouse pointer. We can go back to right. Oops. No, maybe I can just, I don't know how to even go back to writing now. There it is. So, whoops. Based on this, right, based on this little graph here, we could describe what we're seeing, or you can kind of leave it at this. You would say that your results, so results, would be you could just say those that ate 7 apples a week had significantly, or you can just say less if you want to, had less doctor visits in a year than those that ate 0 apples. So hopefully by now you see how this works. You're taking this definition and you're making an overall conceptual definition. An apple a day keeps the doctor away. Healthy eating keeps you well or keeps you from being sick and therefore having to see the doctor. The operational definitions for the correlation, eating more apples or number of apples eaten, right? And criterion would be number of doctor visits in a year. The more you eat, the less you visit, negative correlation. Part 2, you are now making it a little more specific for a manipulated and a measured variable. So your IV is going to be the number of apples eaten in a week. My control group is 0 apples per week because there's no manipulation, like 0 hours of studying, and 7 apples per week, which would be an average of 1 per day. And you could be so specific as to say 1 per day if you wanted to. Your DV, of course, is the number of doctor visits in a year, but you want to make it really specific. So where the visit was for illness and they were diagnosed as sick, just so we know this. Here is your graph, and the results is those that ate 7 apples a week had significantly less doctor visits. Let's say that that's 2, and this one's like 8. I don't know. Than those that ate 0 apples. So the last thing that we wanted to go over, as it says here, is the control procedures. And I asked for 2 or 3, at least 2. So here I'll write control procedures. And what are the things that we want to make sure to eliminate or control for in this? Well, this one should be fairly easy because A, I've done this 100 times, and B, it may be fairly easy to realize what other things could be part of this. So for me, I'll just stick to 3 or 4 of these procedures. So one of the things we want to control for is the rest of their diet, right? Rest of their diets. Because even if they're eating apples, they might be eating McDonald's every meal of the day, and that's really not going to do well for your immune system. If healthy eating, right, you want this apple, everything else should also be on par. So nobody gets to eat really, really super healthy. Nobody gets to eat like crap. So for these few weeks or something like that, or for this year, whatever it is, if they're doing this study for a year, we want to control that the rest of the diet is exactly the same. The only difference we want between the groups is whether or not they had an apple a day. So the rest of their diet has to be controlled for. Otherwise, it doesn't matter because they're eating a whole bunch of other stuff. Amount of exercise, right? The amount of exercise they do, because exercise may be something that keeps them from being sick. So exercise, everybody has the same amount of exercise. Maybe they all do 20 minutes a day, right? We want to know that this is only a result of the apples they eat and not something else. What else could it be? Pre-existing condition. Some people may be prone. Existing. Yeah, existing. Pre-existing condition. Some of them could be prone to getting sick easy because they have a weakened immune system or some sort of already diagnosed thing, right? If that happens, you want to exclude them and make sure that nobody that's still in the study has this pre existing condition, which may give them a trip to the doctor because they're sick, or getting sick really easily, right? We want to know that everything is the same between groups except for the number of apples that they eat. So this is the assignment. This is your example with an apple a day keeps the doctor away. So again, please feel free to use one of these seven, or eight. I mean, is it eight? Yeah, it's eight. Birds of a feather flock together. People that have stuff in common tend to, right? More things you have in common with a person. Fortune favors the bold if you make bold decisions, right? Two wrongs don't make a right. Spare the rod, spoil the child. Blood is thicker than water, which is generally meant to mean family is comes before friends or others. Absence makes the heart grow fonder. The longer somebody is away, the more you want them. Too many cooks spoil the broth. Too many people putting their own ingredients into something may not necessarily make it good. And of course, the tortoise and the hare, slow and steady, wins the race. Because what happens if you rush through an assignment or a race or an exam and go too fast, right? If you're slow and steady, what happens? So those are the ones I gave you. If you want to use one that's your own, fine, as long as you can follow the rules and give it a good conceptual and operational definition. And I hope this tells you everything you need to complete this assignment. Thank you so much for listening. And as usual, this seems to be my call sign or off sign. I'll talk to you later.